Lesson 2-1, Rational Numbers on the Number Line. We'll begin by discussing types of rational numbers, and the first type of rational number is natural numbers. Natural numbers are also known as counting numbers. So if we're going to count the number of people in a room, what number do we start counting with? We start counting with 1. So the first natural number is 1, and every number after that would be considered a natural number. And again, it's also known as counting numbers, so it's the same thing as the numbers we would use to count the number of objects in a set. Whole numbers begin with 0 and include all of the natural numbers. Integers are all of the whole numbers and their opposites. So that would be something like ... -3, -2, -1, 0, 1, 2, 3, ... There are no decimals in the integers, nor are there fractions in the integers. Only the whole numbers and their opposites. And lastly, a rational number. All of these numbers, natural, whole, and integer, all of these are rational numbers. The official definition of a rational number is numbers expressed as a over b, where a and b are integers and b does not equal 0. Numbers expressed as a over b is basically just saying any number that can be written as a fraction. And all of these, natural, whole, and integers, can be written as a fraction. Plus, we throw in other normal fractions and decimals. But the decimals have to be specific. They have to either be terminating decimals or repeating decimals. So rational numbers are natural numbers, whole numbers, integers, fractions, and decimals that are either terminating or repeating decimals. In our first 3 examples, we're asked to name the coordinates of the points graphed. In number 1, the first point is -9, second point is -7, -6, and -3. There is no pattern. Neither arrow on the left or the right is shaded in, so that would be the final answer. There's nothing else to it. We make sure that our numbers are in order from smallest to largest, and we also make sure to include our answer as a set of number, which is why they are in the braces. Number 2, again, I would start off with a brace. 2, 3, 4, 5, and because the right arrow is shaded in, I would end with a ... and then a brace. Lastly, in number 3, because the left arrow is shaded, you should begin with ... -5, -4, -3, and close the brace. These are very simple problems. If you will turn your notes over, on the back side of the notes begins the next couple of examples. They are very similar to what we just did, except in reverse. This time we're given the set of numbers and we're asked to graph each set. So on number 1, we need to graph -1/4, 0, 1/2, and 1. Since fractions are involved, our tick marks on our number line should be labeled with fractions. Let's put 0 in the middle and count by 1/4. 1/4, 1/2, 3/4, 1 whole. 1 and 1/4 will also fit on this number line. To the left of 0, we mirror the exact same numbers, except they're negative. -1/4, -1/2, -3/4, -1, and -1 1/4. Then we place our points on our tick marks. We should have a point at -1/4, a point at 0, a point at 1/2, and a point at 1. Please make sure that your points are right on top of the number line, right on top of the tick marks. Do not put your points above the number line like so. That's actually called a line plot. So again, your points need to be right on top of the number line, right on top of the tick marks. Number 2 involved decimals. So again, let's put 0 right about the middle. And this time let's count by 0.5. 0.5, 1, 1.5, 2, and 2.5. And again, going to the left of 0 would be -0.5, -1, -1.5, -2, and -2.5. We should place points at -1.5, 0, and +1.5. But because of the ... involved in this set of numbers, we need to do something with that arrow. The ... is on the right side, so that indicates that the right arrow should be shaded. When you're shading your own arrow, please make sure that it is bigger and darker than the other area. The other arrow. And lastly, number 3. Number 3 is integers that are less than -6 or greater than or equal to 1. First, let's think about what numbers are less than -6. -6 is not less than -6. So that would mean -7 is less than -6, -8 is less than -6, and so on. Or greater than or equal to 1. 1 is greater than or equal to 1. 2 is greater than or equal to 1, and so on. So basically, they're asking us to graph this set of numbers. I'd start off with a left arrow being shaded because all of the numbers to the left of that -8 will be less than -6. Let's fill in our tick marks. If this first tick mark is -8, that means to the right of it, it's getting bigger, so that would be -7, -6, -5, -4, -3, -2, -1, 0, +1, and +2. Again, we have said that the left arrow should be shaded in because of the ... to begin with. Then the next point should be at -8 and -7. Then we skip all the way down here to +1 and +2. And again, because we end with the ... the right arrow should also be shaded. This indicates a pattern. The last topic is absolute value. An absolute value is always the distance from 0 on a number line. It is written as 2 bars. It looks like 2 bars around a number. That would be the absolute value of 13. To show you what that means, I'd like you to look at where the -3 is on the number line. Here's the -3. We say that it is the distance from 0. So let's count how far, in other words, count the spaces between 0 and -3. There's 1, 2, 3 spaces. So we would say the absolute value of -3 is +3. The same situation happens over here with the absolute value of +3. Here is +3 on the number line. Let's count the distance from 0 on the number line, again counting the spaces. 1, 2, 3. Therefore, the absolute value of 3 is 3. You can remember that absolute value is the distance from 0 on the number line because distance is always measured in positive numbers. For instance, the distance between New Madrid and Sikeston will be a positive number. So here we have the absolute value of 8, which is 8. The absolute value of -12, which is 12. The absolute value of 5/8, which is 5/8. And the absolute value of -0.25, which is 0.25.